Hello everyone, welcome back to PMAT0028. So in class we cover section 11.1, 11.2. We talk about factoring, factoring by GCF and factoring by Smiley method for trinomial. In this video lecture, I want to continue with section 11.5 and 11.6. 11.5 we will be talking about the last method of factoring. We're going to use some special formula, and 11.6 we will be learning how to solve equation by using factoring. Okay, so let's get started. So factoring by special formula and solving equation by solving equation. Okay, so this one covers section 11.5 and 11.6. I just want to apologize because recently I just got a very bad allergy. I have very itchy throat, so I've been using some allergy medication already. It just happened a little bit. This is my chronic allergy. You know, it comes every year and goes like every, you know, it comes for like 2 or 3 months and go, and the following next year come again. So just bear with me for an hour, okay? So on the first part, we talk about a special formula. So we're going to use a special formula to factor trinomial and factor some very special algebraic expression. There are 3 formulas, and I want you to memorize it. The first one we call square of the sum. A plus b squared equal to a squared plus 2ab plus b squared. And the second one is the square of the difference, so a squared minus 2ab plus b squared. And the third one we call the difference of squares, so a squared minus b squared, you have a plus b times a minus b. So you see that this is trinomial. You see, this is trinomial. So the first 2 formulas is used to factor trinomial. Some of you is really good at by looking at trinomial, and then you guys can see right away it's the square of the sum or the square of the difference. Most of the time on the test you will see difference of squares, so every time you see difference of square form, you must be able to split it into the product like this. Alright, so this is difference of square, it is square of the sum, and this is square of the difference. Okay, let me go straight to the example, and then you know right away. It's not really too hard, believe me. Example 1. What if I have something like this? 4x squared plus 10x plus 9. So this is trinomial, and you already learned how to factor trinomial in class already by using Smiley method, you know, the try and error method. However, if you guys learn after you guys learn special formula, this one difference is the square of the sum, then you guys know right away that it's in this form, because 4x squared is nothing but 2x squared. Okay, and 9 is nothing but 3 squared, right? So this is a squared, this is b squared, and between them is 2 times let's see, we can factor it. So this one probably we can because this is you see that if we have 2 times 2x times 3, and you see that this is not give you 10x at all. This is 2 times 2 times 3 give you 12. So this trinomial cannot be factored by special formula, nor by Smiley method, because as you see that it's not over here. The middle term here is not 2ab. Yeah, because 2ab right here, this is your a, this is your b. 2ab give you 12 and this is 10. So this is not factorable. Okay, let me give you something that can be factored. Okay, how about this? Example 2. I have x squared plus ax 16. Okay. So you see x squared is in the square form already. 16 is in 4 square, right? So what you need to know, we need to find 2ab. So it will be 2 times b is this, a is 1. It's either invisible 1. So a 2a is invisible 1 and x right here. So 2a b is 4. So you see that this is x squared plus 2a b plus b squared. So this one can write it as x plus 4 squared. Again, I mean, if you're not good at special formula, you can factor by using Smiley method. But this is, you know, when you do a lot of practice, you know right away, you know, x squared plus a equals 16. You can rewrite it in x plus 4 squared easily. Okay. Or how about something like this? Example 3. I have 25x squared plus 20xy plus 4y squared. Okay, so 25x squared I can write this as 5x totally square, right? And 4x squared I can write this as 2y totally square. And this is a, this is your b. Then you let's see 2ab, it turned out to be 20 or not. 2ab, so 2 times a times b. 2 times 5 is 10, 20xy. So here you go, they give you that, right? 2a squared plus 2ab plus b squared, so it become a plus b totally square. Okay. Okay. Or I can have something like this. I have 4m to the 4 minus 2m squared plus 1. So you see that it's minus here, so you have to use the second formula. So you see the 4m to the 4, you can rewrite this as 2m square, right? Right. 1 you can write it as 1 square. So this is your a, this is your b, right? This is your a, this is your b. Oh, I'm sorry, this is 4. Okay, this is 4. So minus 2a, so a is this, 2m squared minus 2m squared, b is 1. So let's see, 2 times 2m squared times 1, it give you 4m squared? Yes, it is, right? So it is the difference of this is square of the difference, so I can write that this is your a is 2m squared minus 1 totally. Okay. I mean, using special formulas, you guys must be able to see, okay, to recognize backward. You know, some of you already know the special formula. You know, a plus b squared, you expand over a plus b times a minus b, and it give you this trinomial, right? And that is forward. That is forward direction. But if you go from here to back to the square of the sum, or from here back to different square of the difference, this is going backward, and it's harder. So you guys must be able to see, to recognize it. Okay, a and b. recognize A and B. Okay. Alright. I can give you another example. Number 8, number 5. I have 162 x to the third power minus 144 x squared plus 32y. You see over there, this is x to the third power, and there's no way we can rewrite it as the sum. No way we can rewrite it as a perfect square. But if you look at 3 terms right here, you see that they have a number and a variable x in common. And in class, I already mentioned that GCF is always priority. You have to check for GCF first, and you see the GCF of 3 terms over here exists, right? And the GCF is 2x. Okay, because 2x is the common one. So x squared, x to the third, x squared is x, and so x is in common. 2 go into 162, 144, and 32 at the same time. So 2x is GCF. So what you have left is 81x squared minus 72x minus plus 16. And you recognize right away this is a trinomial, right? This is square and 1 and a number. This is trinomial. So, and this is different. They have minus right here. So it means that if it is factorable, then we must use the second formula. Okay. Let's say factorable or not. So 81 is nothing but 81 is 9x squared, right? And 16 is nothing but 4 squared, right? So this is your A, this is your B. Let's see, 2AB minus 2AB. 2AB give you 72. Yes, it is. So it is. So it means it's factorable by special formula. So you have 2x times 9x is your A, your B is 4, totally squared. Okay. All right. Okay. So on exam number 6, I give you example on division of square. Division of square is easy. What if I have something like that? I have x squared minus 25. So this is a square. It's in perfect square form already. 25 is not in perfect square form. However, we can rewrite it 25 as 5 square, right? Then it's in perfect square form. So you have x squared. You have a squared minus b squared, which is a plus b times a minus b. Done. Okay. So this is very simple. Or I can have something like this. If it is plus, then we don't have it. Okay, it must be minus. Or what if I have something like this? I have x squared minus 9 over 16. Okay, so the first term in perfect square already. The second term is not. So it means what? It means that we have to convert into perfect square, and 9 is nothing but 3, 16 is 4, totally square, right? Then I can, this is in the perfect square minus another perfect square. I can rewrite it as x plus 3 over 4 times x minus 3 over 4. Okay, very easy. Alright, let's do another one that is harder. Okay. What if I have something like this? I have 25x squared minus 9y squared. Alright, 25 is, you recognize, right? 25 is 5 squared, 9 is 3 squared, right? So 25x squared, I can rewrite it as 5x totally squared, right? Because I try to convert it into perfect square. 9 squared I can rewrite as 3y squared, right? Then this is a square minus b square. So you have a plus b times a minus b. Okay. I'll be back. I go get some water. I'll be back. Sorry, guy. This allergy is killing me. Hopefully, it will be gone in the next few months. Okay. So, so the job is to bring into perfect square. Okay, perfect square, and it must be minus. If it's a plus right over here, you know right away you cannot use the difference of square. No, right? It must be minus. Okay. Or I can have something like this. So this is example 8. What if I have 4x to the third minus 49x? Do you see any square over here? No. No. But there's something in common. GCF is priority. So x in common, you take x out. So what you have left is 4x squared minus 49. And 4x squared minus 49. 4x squared we can convert into perfect square. 49 we can convert to the perfect square. So 4x squared is nothing but 2x totally square, right? 49 is 7 square. Okay, so on the test, I want to see this step. I want to see this step. Okay, on the test I want to see this step. Otherwise, you won't get perfect credit. Okay, and this is a squared minus b squared. This is perfect square already, so I can write as a plus b times a minus b. Okay. Okay. So it depends on each problem. Sometimes you can apply difference of square right away. Sometimes you have to do GCF first. For example, in example 8 right here, we have to do GCF first. Then we do difference of square. Okay. Okay. How about this? What if I have I have negative 49x squared plus 16. Well, if you look at this problem, you see right away 16 I can write as 4 square, 49 I can write it as 7 square, right? But the thing that we don't have difference of square formula with addition, right? We have a square minus b square, a plus b square minus. We don't have a square plus b square. It means what? It means that if you keep it like this, you can do it, right? However, this is the same as this, right? You just switch position. And now, after you switch position, you see right away 16 is 4 square, 49x squared, we write it as 7x totally square, right? Right? And what? A square minus b square. So a over here is number 4. So give you 4 plus 7x, 4 minus 7x. Okay. Remember, for addition, we have a commutative property. Meaning we have a plus b is equal to we have associate. No, not associate. It's yes, it is commutative. We have a plus b equal to b plus a. However, for subtraction, we don't have it. We don't have a minus b equal b minus a. We don't have it. So this is a, this is your b. So you have to write 4 minus 7x. You cannot write 7x minus 4. If you write 7x minus 4, will be wrong. Okay. So basically that's all the example for a special formula that we use to factor algebraic expression. Okay, on the second part of the lecture, which is in section 11.6, I want to show you how to solve equation. Okay, so equation and by factoring. It means what? It means that any equation, not all the equation, but some of the equation, we can solve by put in the product form. Okay, product form is factoring. You see this product, all of them product. Okay, if we can put into product form, then it's easier to solve the equation. Of course, not all the equation can be put into product form, but if we can put into product form, it means we can solve equation. Okay, and after you put product form, after you factor, you have to you have to use a property. We call that a zero product property. Zero product property. Some of them, some textbook we have another name. Sometimes we call it zero factor property. Okay, so I want to talk about zero product property. So this property, it helps you to solve equation after factoring. And the property states that if we have a times b equals 0, then it implies a equals 0 or b equal to 0. Not and, okay? Must be all. Okay? And I want you to memorize this. Okay. I mean, so if you know zero product property, you can factor, you can solve a quadratic equation. You know, back in the day in high school, you learn how to solve quadratic equation by quadratic formula, right? But if you could think about it, if you can factor the quadratic expression, then you can solve the equation by set each of the term. Okay, each of the factor, I'm sorry, equals 0. Okay, for example. What if I have this? What if I have let me see. What if I had this? X minus 3 times x plus 1 equals 0. Is it in product form? Yes, because it's a dot sign right here. It means what? If you apply zero product property, I can split up x minus 3 equals 0 or x plus 1 equals 0. Then you can solve for this easily, right? Alright. But of course, it's not always that the equation is in product form. I mean, we have to factor. Example 2. What if I have something like this? X squared minus 9x minus 22 equals 0. This is quadratic, right? And it's not in product form. But let's check it is factorable or not. If it is factorable, we can solve it quick. So we're going to use my smiley method. Last in class we already learned. So x factor of 11 is a factor of 22 is 11 and 1, right? 11 and 2, right? So you can have negative 11 plus 2 here. Equal to 0. And now I just put in factor form. It means I can use product property to split them up. So you have x equal to negative 2, x equal to 11. Okay. Alright. I mean, you see that if it is in factor form already, then we can apply the zero product property right away. But if it's not, then you have to put into the product form before you can apply zero product property. Example number 3. What if I have something like this? What if I have 4x squared minus 28x equal negative 49? Is it trinomial? Yes. It doesn't look like at the beginning because over here you have the negative 49 instead of having 0. But just think about it. If you move negative 49 to the left hand side, so it becomes positive 49, 0 on the right hand side, right? And you see that. Can you factor this? Can you factor this? Can you factor this? You see that this is we can use square of the difference, right? We can use special formula. 4x is nothing but 2x squared, right? 49 is 7 squared. So minus 2ab, 2a, this is your a, this is your b. So when it's 2ab, let's see it turn out to be negative 28x. If it turn out to be negative 28x, then you write. So 2 times 2 is 4, 7, 20. Oh yeah, it is. So this is it means that over here I can rewrite as 2x minus 7 squared equals 0, right? Right. And 2x minus 7 squared is nothing but 2x minus 7 times 2x minus 7 equals 0, right? Right. Then you see in product form, so I can split them up. I can write 2x minus 7 equals 0, or 2x minus 7 equals 0. Right? Why you don't have to write? You don't have to rewrite it like that anymore because it's repeated. So you just need to write one of them and solve one of them, so x equals 7 over 2, and you're done. All right. So basically that is the how you use zero product property. You try to bring it to the trinomial, or you then you bring it into product form. Okay. Then you can solve it easily. All right. What if the equation is like this? The equation is it has 4 terms. What if it has 4 terms? What happens? You remember in class we learned how to factor by grouping. Remember that? If we can factor by grouping, then it means what it means that we can solve for the equation also, right? We can solve for the equation also. Okay. Because factoring by grouping is also factoring, right? And factoring is putting in the product form as a property, and you can split them up and you can solve for x. Okay. All right. So I think that's all for a video covering section 11.5, 11.6. Please, if you don't understand any, please let me know right away. But this is the easy concept, so I think everybody get it though. It's not really hard. You just do a lot of practice, then everything will be fine. Okay. Then I'll see you next time in the next video. Bye bye.